This is Houston, contact with a test 1.
Touchdown confirmed.
Hi and welcome to Space Cowboys podcast number 3.
Number 3.
Welcome to you, Thijs Roes.
Yes, thank you so much. And thank you to all our listeners and to our Patreon supporters for supporting us.
Yes, and please do support us.
Yes, awesome.
Go to patreon.com/Space Cowboys.
And you can support us there. And today we're going to have a great show.
Yeah, today's topic is Oumuamua. I practice that.
I have not. Can you please do that slowly once more?
Oumuamua.
Oumuamua.
That's right.
The big cigar-shaped thing.
Yes, it was an object originated from outer space, from out of the solar system, and then it disappeared. And it was extraterrestrial, but the question is, was it natural or was it made by extraterrestrials?
Yeah, I mean it's from outside the Earth, I guess. So it's extraterrestrial,
yes.
But it's even from outside our solar system.
Yes, it had such a speed that it had to come from outside, and it also disappeared into the great void.
It just
came
zapping by. Oh yeah.
Yes. Well, it's not out of the solar system yet, but it's
So
on its way.
if you see something flying by that's like,
it's got to be
sort of like, yeah. Well, at least it's not part of your solar system because it goes way too fast.
That's right.
Yeah.
And we're going to discuss the interesting questions about Oumuamua. If you do it quickly, it becomes more difficult. Oumuamua. We're going to discuss the questions with Seth Shostak. That's difficult as well. Seth Shostak from the SETI Institute in Mountain View. Hi, Seth.
Hi, how are you?
He comes to us via Skype.
Yeah, thank you so much for being on the show, Seth. It's really wonderful speaking to you.
Oh, it's a pleasure, Thijs.
And the fun fact, Seth used to work in Groningen for a couple of years. It must have been, Seth, right?
Yes. Well, it was 13 years, believe it or not, although I think I only spoke about 8 words of Dutch while I was there. What was such perfect English?
What was the best word you learned that you remember?
The best words I learned in the cinema, in the movies, because they would be subtitled. Mm-hmm. And there would be these strange words that would come up occasionally. And, of course, I could hear the English. And they were usually swear words, dirty words, words not used in polite company. And all of those I learned at the movies.
We'll not do the bad words in Dutch. We'll save that for another show. But gezellig I always like. Gezellig, the most Dutch word there is. It's being close together and it's warm. Right now, this can be a gezellig conversation.
Yeah. And of course, Seth, we have our national test of Dutchness, which is Scheveningen. Can you say Scheveningen?
Scheveningen.
That's very good.
Well, maybe better than the Germans during the war.
Yeah.
Okay. What we do each and every week is we tell each other the best story of the week, the best space story of the week. Would you care to begin, Seth? Do you have some good story that you heard or read this week that you might want to share with us?
Well, I think it may be slightly more than 7 days ago, but I'm not entirely sure.
We don't care.
That's all right.
Yeah, well, it's a week on Mars or something. I don't know, but it's actually it's not. Come to think of it, but the story was the discovery announcement by Canadian astronomers that they had discovered a new fast radio burst. And a fast radio burst is exactly what it sounds like. It's a very quick radio signal from the heavens, and they picked it up with their new telescope. It's called CHIME, and it's located in British Columbia, which is western Canada, in the mountains and woods up there. Yeah. But what's interesting is that this particular radio burst repeats, and there's been a lot of speculation. There's been some speculation that maybe these bursts are caused by aliens trying to get in touch.
Ooh, and how will we know? For sure. Well,
here's my prophecy of what's going to happen. Mm-hmm. There have been something like 60 radio bursts found. Only 2 of them repeat. The ones that repeat, that's a good thing, because when they repeat, you can go back and look at them again and maybe use a different kind of telescope, different kind of instrument. You can study them enough that you might be able to figure out what's going on here, because whatever it is, it requires an enormous amount of energy. So nobody knows. It's a mystery of the cosmos. My projection is that within a year, some clever theoretician, somebody sitting behind their desk, not at a telescope, sitting behind their desk, is going to figure out what these things are and publish a paper, and then we'll know. But until then, it could be, I don't know, colliding stars, except colliding stars don't do it more than once, so that's a little peculiar. It could be a whole bunch of stuff that people have sort of thrown out there, and it even could be aliens. Mm-hmm. There's a fellow you guys know at Harvard who has suggested, well, don't rule that out. Yeah. I've ruled it out. I think you'll be able to rule it out. But in any case, it's the big mystery, and I've gotten a lot of phone calls about it.
Yeah, and we love mysteries, of course. Sometimes the mystery is better than the real-world explanation, right?
Yeah, no, that's absolutely the case. And if you think what the job description for astronomers is, well, it's to find new stuff, not to find old stuff. Astronomers don't go out and get behind the telescope and say, well, let's see if the moon's still there. I mean, that's not going to get them tenure anywhere. They're not going to get a permanent job that way. The idea is to find something new, and this has been a hot topic for a while.
You keep digging into the weirdest spots. Yeah, isn't there? I have one question. Isn't there some sort of list? I remember Carl Sagan once writing about it. Some sort of list of a couple of anomalies, sort of high energy beams, or some sort of signal, and they are still unexplained. There's this short list of things, we still don't know what it is, but it's a lot of energy coming at us.
Well, I don't remember that from Sagan, but it's quite possible. I mean, in a field such as the one I'm in, where you're trying to find signals that'll tell you that, the aliens are out there. In the old days means 30 years ago, whatever. In the old days, you would find a signal that, looked pretty promising and had the characteristics you'd expect for something coming from way beyond the Earth. And, but you wouldn't find it again. Yeah. And that's always a problem in science. If you measure something and you don't find it a second time, you can't really do much. I mean, if Newton had only had an apple fall on his head once, we probably wouldn't have all that physics.
Exactly. A sample of one is terrible.
But to be sure, Seth, and although you're from the SETI Institute, Search for Extraterrestrial Intelligence, you do expect for these radio bursts a perfectly natural explanation, okay?
I do. But, I think history's on my side there. Yeah. If you think back to the discovery of the pulsars, that's the perhaps most famous example. That was found by people in the UK, in England, Cambridge, and they found this radio source that would very regularly shoot radio beams at you, psh, psh,
yeah.
Right. It was very, very precise. It was better than any clock they had. Right. And so for a while they called them LGMs, Little Green Men.
Little Green Men, yeah.
They did that for a couple of months until they found a second one and then a third one. Then they decided, well, this is probably something natural. And it turned natural.
It's so funny. So pulsars used to be called Little Green Men.
Sure.
Yeah. But they were for a while. Yeah.
Yeah.
But of course, if a signal is too regular, it's probably not a signal from an intelligence, because if they have to tell us something, they won't use a signal that just repeats.
Well, that's true. There's not much information in a signal that. So, you can't send your favorite poetry or anything, but you could concoct a scenario. I mean, maybe it's a clock. There's a radio station here in the United States run by the U.S. Navy, and it's just a clock. All you hear is... and it was for navigation purposes, still is, okay? And it's very, very precise. I mean, it's extremely precise. And, there are reasons why you want to have very precise clocks. Think of GPS satellites. They have to have very, very precise clocks. So, it could be that the aliens just have this set up as the Galaxy Time Service or something like that. But it turned out it wasn't that. It was a natural phenomenon.
Okay.
Well, we're still at our stories of the week.
Yes, let's continue. What's your story, Thijs?
Well, I came across something real fun. It's there's some art on the moon right now. Well, to even go back further, is there a lot of art in space? Not that much. There's been a lot of exploration, but some people want to really change it. But
like art made by artists.
Yeah, art made by artists. I think there are some artists going up to around the moon with SpaceX, but this is a different project. It's an art gallery on the moon. There's this group of people who want to create an art gallery on the moon because they're saying, hey, there's a statue on the moon, but no art gallery yet. So it's they're going to be really mini artworks of about a centimeter by a centimeter and then 10 by 10. So the whole grid will be just 10 centimeters by 10 centimeters, and there will be 100 little art pieces.
And that's the entire gallery.
And that's the entire gallery, and it needs to go on a moon lander. And Anna Sitnikova, I spoke to her over the weekend when they opened up the new version of the gallery at ESA. And I have a little clip for you, and she can explain where the artwork will go on. It's going to be on some sort of lunar explorer on the ESA project.
Let me see the Moon Gallery.
So we plan to launch Moon Gallery in 4 years with the European Space Agency lander, perhaps. And we're working in close collaboration with Bernard Foing, who was the father of Smart One, the first European mission to the moon. So we really hope that he helps us bring Moon Gallery to space. And we actively participate in conferences where we meet the different space agencies and discuss Moon Gallery. And I really can feel good response and interest in the project. And I'm sure we will find a way to bring it up.
Yeah, so they're still working on getting it up through ESA. They're having an open call, so anybody can send in their artwork through moongallery.space. And what was funny is that they, I asked, because last week we had that conversation about the planetary protection officer at ESA, that I was sort of like, well, if you ask 100 people to give artwork, like, will none of them be sort of like dangerous or something like that? And she said, well, we thought about it, but she said following.
We really are trying to develop it being sealed from outside world. On the other hand, we want to give artists freedom to think outside the gallery, and maybe something can deploy, a smaller project could deploy and extend beyond this format. So we don't want to limit the artistic thought anyhow, and then later on we will find a way to make it.
Okay, I'm looking forward to having this reason to go to the moon.
The reason to go to the moon. Well, it's going to be part of, and she explained it, there's a Swiss moon mission that's being built and that they're working on. So to get the 2022, something like that, that's what it's planned for.
Okay,
yeah.
Well, I'll tell you my story. It's
moongallery.space. If artists are excited to have their artwork on the moon, moongallery.space.
Moongallery.space, the .space top-level domain. That's beautiful.
Yeah.
Okay.
Your story of the week.
Yeah, my story is about the Chinese moon lander that's on the far side of the moon right now.
Aha.
It had an experiment on board with plant seeds and a couple more things. There was yeast even and fruit flies.
Yeast and fruit flies?
Yes, it was supposed to be an entire ecosystem. Mm-hmm. And it was mostly a failure, but the cotton seeds germinated. So they have the honor, the Chinese, of having put the first plant on the moon.
Yay.
And that's very
What do you think of that, Seth?
Well,
it's an extraterrestrial life, right?
Yeah, why wasn't it the Brussels sprouts or something? I mean,
yeah, or
cotton. Why cotton? Yeah. Well, maybe cotton grows really well on the moon. Who knows?
Yeah,
we'll get our cotton from the moon.
That cotton.
Yeah.
Okay, but
it's great. I mean, I saw the picture. It's pretty bizarre. Still,
it was a lovely, tender little plant.
Yeah, but just that image of just seeing a plant on just a different world is just a bizarre image.
It's crazy. Yeah. But it died.
It died. I thought it. I mean, last thing I heard was it lived.
No, it also died.
Okay, so it germinated and then it died.
And it was supposed to, because the moon night came by, and it lasts for 14 days, and the temperatures go down to minus 170 degrees centigrade.
Oh.
And no plant is going to survive it. But I believe it died even before that.
I hope it did. Otherwise, it was in pain.
Yeah. Okay, so that's my story.
Yeah, awesome.
Let's go.
Yes, to the main topic, but not before we thank our Patreon supporters.
Let's do that once more.
Yes, you can go to patreon.com/spacecowboys, and you are what make this show possible. So thanks for that. And also want to point out that we're on YouTube, we're on Spotify, we are on basically any
Just
podcast
look for
app that you
Space Cowboys podcast and you'll find us.
Yes. Yes, exactly.
All right. So in October 2017, there was an object discovered, and it had a velocity so high it had to be from outer space. It was not part of the solar system. It just dropped by and left. The name was Oumuamua, and that means first distant messenger in Hawaiian. And indeed, it was the first object that with certainty was from outside the solar system. Very interesting. There was some controversy around it, and we're talking to Seth Shostak of the SETI Institute in Mountain View about Oumuamua. Seth, did you notice Oumuamua when it was discovered, or did you hear about it only later?
Well, I think I heard about it just at the same time that anybody else would have heard about it. There were some press releases. I do get astronomy press releases, so maybe I probably had a few days early notice.
Yeah, there's no big red flashing light next to your desk somewhere, like a hint has been found.
No, they're only about when it's time to go to lunch. No, there was no particular notice because. I mean, this thing, it looks like another rock in the solar system. Well, there are billions of rocks in the solar system, but this one had a funny orbit. That was the deal. Yeah. It wasn't particularly going it wasn't going really much faster than any other asteroid, but it had an orbit. Calculating the orbit of these things is that's pretty old astronomy technology. We know how to do that. Yeah. And it turned out that it had an orbit that, extended way beyond the solar system. It wasn't from this set of worlds. It's not one of the suns. So this was the first time we'd seen anything like a rock that had come from somebody else's solar system. Did
that make a big impression on you? Do you remember where you were when you heard?
I don't. It didn't make that big an impression. No, but I have to say, the bigger impression was not that there was a rock from another solar system, although in retrospect, I have to say that I should have been more impressed. But the thing that struck me was it was discovered by this telescope in Hawaii, and that's why it has a Hawaiian name, I assume, that had only been in operation for about a year when it discovered this thing. So what that tells you is that, whatever this thing is, there are probably a lot of them, because if you turn on the telescope and within a year you already find one of these things, there must be, they must be entering our solar system all the time, and we just never knew.
Yeah, and was this telescope made? Was that like a whole project to find objects like this, or was it just zapping by without us?
It's a telescope that was sort of optimized, sort of designed, if you will, to find things like this, if not, just extra solar system objects. Fundamentally, you see, the way telescopes have always worked in the past, the way astronomy has always worked in the past, you decide, okay, I'm going to study this galaxy, and you get a night of telescope time or whatever, and you go up to the mountain, you make some photos of it, and it takes a couple of hours and whatever, and you process the photos, you put them in your desk drawer, and a couple of weeks later you look at them and whatever. Yeah. But that means, that's fine, but what astronomers never were able to do was to get pictures, every couple of days of things, right? Mm-hmm. That was something that wasn't possible. But when photography went to the, if you will, the electronic realm, when it no longer was a chemical process, and suddenly was much more sensitive, and you could process it without doing much of anything. You just connect it to your computer and you can see it. It was possible to change all that. So this telescope would take pictures of the sky, and then it would come back and make another picture of that same part of the sky maybe a few days later. So then you can do something that's, very simple. You just set up the two pictures sort of side by side with a little optical device that you push a button and it shows you the first picture, and then you push the button again and it shows you the second picture, and just back and forth. And they should be identical. Things in the sky don't change very much unless there's an asteroid in the picture, and that will seem to move among the stars there. So, and in fact, even that's been automated. You take the people out of the equation altogether.
Yeah, I would say that nowadays there's algorithms, I would say, or not, that can find objects like this quickly. I mean, is that part of this?
Yes.
Yeah. So have we found even more?
No.
No? Okay.
No, not to my knowledge. No, the only one that's been found that, is certifiably from beyond our solar system is Oumuamua so far.
So that was special to begin with, but there were more weird things about it. One, for instance, was its rotation, at least its variation in brightness, turned out to be 10 times as long as it is wide. How unique is that?
That's very unique. I mean, people have seen pictures of, asteroids. We've had, the Europeans, remember, they visited one. Okay, so they're shaped like.
You're talking about the Ultima Thule right now.
No, that's not so much an asteroid. That's just a sort of.
Oh, sorry. Yeah, I'm confused. Yes.
Yeah. No, there have been missions to asteroids, several missions, because
the other one.
Yeah.
The Japanese one.
Seeing this was already a whole undertaking, this Oumuamua, but then going there is an even bigger undertaking because it's even going faster than the solar system. So it would be really hard to visit, I would assume.
It's moving at about, 10 or 15 kilometers a second. Something like that.
Okay.
It's not particularly faster than anything else, but it's
just like, let's go there. I can't wait to go there.
Rockets, that's the problem.
It's too late now, I guess.
It would take a very special rocket to catch up with it. But this very odd shape that you talk about, that was implied by the changes in brightness of the thing. I mean, the thing is so small. It's I don't know, maybe couple of hundred meters long. That's pretty small when you're looking at it from millions and millions of kilometers away. So it's just a dot on the photos. But what you can do is you can see, was that dot getting brighter, dimmer, brighter, and it does over the course of hours. So it's obviously moving around and
flashing.
It's tumbling. So you can do some analysis and decide, well, it's kind of shaped like a cigar. And I think most people have seen this artist's impression of Oumuamua, which looks like indeed a long cigar with a rock. But that's in the mind of an artist. Maybe we should put it on the moon. But that doesn't mean that's what it looks like.
All right.
So what did you think was so fascinating about it, Herbert?
Me?
Yes.
Well, I only woke up, so to speak, when Avi Loeb showed up in the media. Mm-hmm. He's an astronomer from Harvard, and he was on the After On podcast by Rob Reed, an interview that lasted more than an hour. Yeah. And he explained everything that he thought was strange about Oumuamua.
We'll learn Hawaiian. Yes, our Hawaiian is about as good as Seth's Dutch.
And let's just go to a couple of the things that he explained were strange about it. And the first he explains is about the velocity of this thing. Here he comes.
Yes, the speed is an interesting story by itself because this happens to be the so-called local standard of rest you get when you average over all the stars in the vicinity. So stars have relative motion to each other, and so you can take the average of that motion and find the local standard of rest. And it so happens that Oumuamua is originating from that frame of reference. It's almost at rest relative to the local standard of rest. And only 1 in 500 stars is so slow relative to this frame of reference. Now, if you wanted to camouflage your origins and hide where you came from, you would be in that frame because that frame does not belong to any star. Only 1 in 500 stars is in that frame, and Oumuamua is in that frame.
Okay, so my question to Seth is, do you agree that this object, Oumuamua, has had a very special speed?
Yeah, well, in that regard, what Avi Loeb is describing there is that relative to all the stars that are within, I don't know, maybe 1,000 light years or something like that, 500 light years, whatever, the local standard of rest. It's like, the way you can think about it is you're going down the highway, right? And there are a whole bunch of cars going down the highway, and they're all going on, who knows what, 100 kilometers an hour, whatever. Mm-hmm. And so even though they're moving quite fast, relative to one another, they're not moving all that fast. That's why you can actually do this, right? So there's kind of a local standard of rest, of motion for all these cars on the highway. You can think of it that way. So Oumuamua, relative to the stars nearby us, was moving at the average speed of all those things. And that is, as Avi Loeb points out, that is rather special. That is a rather special speed.
Yeah.
But that doesn't mean that it's not a natural object. It just suggests it might be.
It could be a coincidence.
To me, it sounded a little reversed, like a reversed logic. But
explain to me.
Well, it sounded like a stretch. That he said there's like a chance of 1 in 500, and then But so if it wanted to hide itself, it would do a really good job. Yeah. And that's sort of like, well, but like Seth is saying, well, it's special, but it can. We just found one of these objects. Maybe there's like a trillion of these tiny objects.
Yeah, Tice has a good point there, because indeed this is sort of ex post facto probability in a way. Mm-hmm. It's like saying, I grab.
It would be special. That's what you're saying.
Well, yeah, I mean, there are going to be some special things about it. Now, I grab my dog here, right? And I notice, hey, wait, one of his ears is white and the other one is black. And only 1 in 500 dogs has ears that are like that. That might be true.
Some significance.
Yes.
Yeah, right. Exactly. This is I'm going to have this dog, put on display.
Yeah.
Yeah.
But there's more, of course.
Well, so speed. So we can sort of, if we keep a scorecard, then speed. Yes, it's sort of special. It's weird.
Okay. So then Oumuamua appeared to accelerate when it shouldn't. It was moving away from the sun. And because of the sun's gravity, most objects decelerate then. But Oumuamua accelerated. Comets do that, but Avi Loeb has trouble believing that Oumuamua is a comet. Listen.
Comets have ice on their surface, and this ice, when it's warmed up by the sunlight, it evaporates, and you end up with a situation similar to a rocket, where there is gas flowing in one direction and pushing on the exhaust in the other direction. And so the idea is that in principle, comets deviate from an orbit that is shaped purely by the sun's gravity because they have this extra push from the gas.
Which is called off-gassing, correct?
Outgassing.
Outgassing, yeah.
Now, the only problem with this idea is that we haven't seen any cometary tail. There was no evidence for either gas molecules in the vicinity of Oumuamua or dust, which is often accompanying the evaporation process.
Did we look closely enough that we really should have seen it? I mean, we had all those telescopes pointing at it.
Yes.
And also there was no coma, right? Which is the fuzzy area that surrounds the front of a comet where stuff is also outgassing, correct?
Right. And also, just the other day, I made a rough estimate. If you ask which fraction of the mass of Oumuamua needs to be evaporated in order for it to get enough push, it's actually substantial. It's more than 1/10 of its mass.
Would have had to outgas in order for it to get that thrust. And is that atypical of what usually outgasses from a comet?
Well, not so much that, but you would notice it because there would be a lot of stuff.
Yeah. When the paper came out, I read interviews with a couple of the scientists, and they did acknowledge, hey, it is kind of weird that there was no tail. One of them said, well, that might be because instead of small particles, which for whatever reason are easier to see, the tail may have been comprised of large particles, which are hard to see. And I'm not equipped to parse that argument. How do you respond to that?
Well, there are other effects that outgassing has on an object, because usually the comets are not symmetric, and so they're not pushed just away from the sun, they're also pushed sideways. But moreover, they get spun up or spun down. There is a change in the spin period of these comets. And
there's an eccentricity to the rate at which it's spinning.
Yeah, well, the force is not even on the two ends of the comet.
As a result of the outgassing.
Yes.
Yeah.
And as a result of that, the period of rotation is changing, and the change should have been easily noticed. That didn't show up.
So there's a lot going on here, but to wrap it up, on the one hand, it should be a comet because it accelerates away from the sun. On the other hand, there's a lot of arguments to make that it can't be a comet. Seth, what do you make of it?
Yeah, well, Avi makes a good point. I think, he makes several points to argue that this thing doesn't seem natural. And I think that this is argument maybe number 2 in importance, that it flew away from the sun as anything, would. I mean, there are plenty of asteroids and comets that go around the sun in our solar system. It's happening all the time. And, thanks to Newton, you can predict exactly how they should do that. But this thing, as it was pointed out, it spun up a little bit. It sped up a little bit. It came off the sun, if you will, a little bit faster than it should have, just based on its, the mass of the sun. Just Newtonian physics. And the usual explanation for that is indeed that a little bit of ice sort of boiled off the thing when it got near the sun and acted as a rocket and accelerated it. And Avi points out, yeah, but we don't see any evidence of ice coming off this thing. And so, yes, that's true. But again, the measurements were made of this thing after it had gone around the sun. I mean, this thing was discovered when it was already on its way out the door.
Yeah,
right.
That's true. Yeah.
So it wasn't very close to the sun anyhow. And when you don't see anything there, you could say, well, it could be that it's, it's not a comet, it's a solar sail or something like that. Mm-hmm. You could say all that. But on the other hand, you don't really have good enough measurements to make that totally convincing. I think that's the only excuse, the only smooshia that you could make here, that it might indeed still be comet or like a comet having ice on the outside, and we just didn't have good enough observations to see that. That doesn't sound like a very strong argument, but I think it's true. This thing barely had any data because it was so tiny and it was on its way out.
Yeah.
Yeah, sounds sort of like the same argument, yeah.
Yeah. You say this is number 2 in importance. What would you say is number 1 in importance as far as the arguments of Avi Loeb are concerned?
Well, I think he makes a good point when he says, look, if this thing just sort of wandered into our solar system by accident, which is kind of the default assumption, mm-hmm. then you can do a very sort of quick calculation and say, okay, look, they turn this telescope on and a year later they find something entering the solar system. Yeah. It's like, I don't know, if I suddenly pull the curtains on my living room windows and I look outside and there's a cow in the front lawn, I can sort of say, there must be a lot of cows wandering around this neighborhood, because otherwise, what are the chances that I just open the windows and there's a cow, right? Yeah. So I got to tell you, I don't see any cows here, but in Holland,
okay,
so it's all right.
But there's no. I see cars only. There's cars,
only
cars. No cows. Yes. There are a lot of cars here, too. Yes. Bikes, cars and bikes.
Okay, so his argument is, look, either there's just an enormous number of these rocks cruising between the stars, and you can work out that number, and it's a very, very big number, which seems a little unlikely. I agree with him there.
Or somebody shooting them at us.
Or somebody is aimed at you. Yeah. And that strikes me as a pretty interesting argument.
Mm-hmm. Somebody? I mean, can it not be something, like an explosion or something?
No,
but to me like a stretched sort of thing. Like, can it not be just something that exploded and came our way?
Yeah, no, because how would the explosion decide, I'm going to explode in just such a way that all the shrapnel is going to, or at least some fraction of the shrapnel is going to go to that little star system over there, right?
Yeah.
Seth, what I find most convincing is the multitude of arguments that Avi Loeb has. I mean, there's the fact that this telescope saw something so quickly. It's the acceleration thing. It's also the shape. It's also the fact, which I haven't even mentioned yet, that it does not absorb solar light very well. There have been measurements to find out if it warms up at all by solar radiation, and it turns out that it doesn't do that very well. So there's lots of stuff there, and all these together form a mystery, to me at least. Don't they do that for you?
Well, it's true. You could say, look, no single argument is going to convince everybody because, right, we don't have what they call the smoking gun here. Mm. But we've got all these other arguments, and that should convince you. Well, that's exactly the logic that was used back in 1996. That's a long time ago now, but the big science news story of 1996 was a meteorite that was picked up from Antarctica called ALH 84001. Wow. And there were scientists at NASA and a guy at Stanford here up the street who argued that if you open this thing up and looked inside with a microscope, you would see these little squiggly things that were fossilized Martian microbes. And to support that conclusion, I mean, these are serious scientists. And in fact, most of them still are, right? I mean, one of them died. That's the only reason I make that.
They haven't been thrown out.
Yeah.
Of the community.
Well, it isn't accepting, but they argued in their initial discovery paper that, there's no single thing that proves that this is Martian microbes, but here are 6 pieces of evidence that suggests that it must be. It has, carbon content, and it's got this squiggly shape, and it's got this, and it's got that, and they hoped to convince the science community on the basis of the fact that here were 6 rather, interesting facts about this that would, in totality, you would say it's pretty impossible to believe that with all 6 of those things happening, the big conclusion that it's actually Martian made. So, just because you have lots and lots of clues that point in one direction, you do have to be a little bit careful.
Well, back then, Bill Clinton commented on it, I believe, even. Said, like, we now, in the Rose Garden, I believe, he said something like, we potentially had this, have found Martian life now. It was like a hype. And, it's still always cool to quote him on it, And, if you... we've been disappointed before. And, like, the space exploration is a string of disappointments, too.
It isn't to say that Avi Loeb is wrong, but only to say that this is not an airtight argument. And Avi is a very, very creative guy. He's the head of the astronomy department at Harvard, and he has a very fertile brain. I mean, he comes up with lots of ideas. In fact, we talked at the top of the show here about this fast radio burst that was just discovered or just announced, in any case, by the Canadians. And Avi said, don't rule out the possibility that these fast radio bursts are due to aliens. Well, I'm willing to bet you my next month's paycheck, which of course, but I'm willing to bet that.
Yeah, sure. How big is the bet?
I don't believe. I don't have the clip, but I don't believe Avi considers he has proven the extraterrestrial origin. No. He doesn't.
No, he's not a crazy guy. He's a very competent.
He just tells us we should consider the possibility, right?
Exactly. But he does that with other discoveries. And I appeal to history here because in the law, precedent counts for something, and I think in science maybe too. We mentioned that the pulsars were originally called little green men because nobody understood what they were, and it could have been that there was an alien signal. The quasars, that's even older. The quasars discovered in the 60s, but the early 60s, the Russians, the Soviets at that time, some of them were saying, look, this is alien signaling. Okay, there are people who, when the spacecraft, what mission? Anyhow, the Galileo mission, I guess it was. No, Cassini. Sorry, the Cassini mission went around Saturn. Right. You look at the top of Saturn and you see this big pentagon there. Right?
Yeah, exactly. Yeah, beautiful.
It was a hexagon, I guess.
The hexagon. Yeah.
Well, hexagon and pentagon, they seem to depend on the day of the week. But
Pentagon is in Washington.
Cosmic background radiation is another example. Also unexplainable. Maybe it's aliens.
But on the other hand, Seth,
they thought it was birds for a while.
Sorry, Seth. They thought it was.
Well, it was thought to be birds when it was first discovered.
Birds.
but birds are kind of alien. But the whole point is you discover something you don't understand at the beginning. That's always what happens. Mm-hmm. Of course, it's what happens. Yes. And there are always going to be people who say it could be aliens, and it could be Tabby Star. Remember Tabby Star? That's 2 years ago. But one of the astronomers at Penn State University came out and he said, it could be an alien megastructure. It could be a Dyson sphere. It could be something built by aliens, which it could be.
Could be. Yeah.
Okay.
It's a workable theory. That's at least
your logic is totally sound, and I believe you. You convince me, etc. But on the other hand, you're from the freaking SETI Institute. I would expect you to be a bit more enthusiastic if an object comes by that has all these characteristics. Oh, I'm getting confused here. Characteristics that Oumuamua has.
Yeah, well, look, Herbert, I get that every day. People call and they have something to tell me. They usually, precede their conversation with say, I have something very important for you. Okay. And I can tell you what that means. What that means
That's a Monday morning for you, yes.
They say, the guy saw a UFO, and, sometimes they send me photos and videos. Those are interesting. But so you think, and then they complain to me when I say, well, I looked at your photos, and honestly, I think that's internal reflection in your zoom lens or whatever it is. And they say, I would think that somebody who's looking for ET would have more enthusiasm about my discovery.
Oh, okay. You hear that, Herbert? You hear that?
I do. Yes. I'm just another crackpot.
So that's my response. Look, we haven't talked about this here, but we used our Allen telescope array. It's an array of antennas up in the Cascade Mountains of California, so about 500 kilometers north of San Francisco, and it pointed it at Oumuamua and tried to see if there were, any radio signals coming from. Because if you found radio signals coming from it, you could say, this is not a comet. This is not a comet.
It's transmitting stuff.
Right. That would be great.
Yeah.
We didn't find anything, by the way, and we weren't the only ones to look. There was another group that also looked.
Yeah, that's important to have negative results and publish them, right?
Mm-hmm. And we could rule out a transmitter with, if it had 10 watts of power, we would have seen it, even if the antenna was not aimed anywhere toward Earth. If it was, just sort of an omnidirectional transmission, we would have found it even with 10 watts. 10 watts isn't a very powerful transmitter.
Yeah. Now, Oumuamua is gone. I think it's past the orbit of Mars or something. I don't know exactly where it is, and it's going really fast. We're not about to overtake it with any kind of human-made rocket, not even if Elon Musk works on it.
You could. Don't underestimate Elon Musk.
How dare you?
Yes. If you made a rocket twice as fast as the ones we have, you could catch up with it. But
we're not going to, right? We had a chance, maybe we had a slight chance, but it's gone.
Unless you're willing to write the check, Herbert.
Yeah, well, not me. We have to talk to Bill Gates about this. But would you have loved to visit Oumuamua?
Of course. Yeah. Of course. It's interesting to visit anything you haven't seen up close before.
That's true.
Right? The Ultima Thule, this rock that was just visited by the New Horizons spacecraft. That, it looks like a peanut, but it was very interesting, and we'll learn things from that. So, sure. But I think that, and Avi Loeb has said this, and I think he's right. The deal is, the only way we're going to sort of decide what Oumuamua was is to find another one. Right? So if you find another one, and presumably we will, then if you find it early enough, now you can study it with every telescope in the world that you can get your hands on, and that may help. And indeed, if it looks again like Avi Loeb thought this one did, if it looks like it's artificial, if it's something somebody built and sent this way, then, of course, I think you would find the money to build a big rocket and go catch up with it and look at it up close and see if it has Klingons inside.
Yeah. So how do we make sure we don't miss the next one? This telescope, of course, that is on the lookout for us, but we also have to have some kind of rocket standby to be launched if necessary.
Well, I don't think you're going to get that.
Huh.
I don't think you're going to get the rocket ready to go. That would be like saying, somebody could break into my apartment here, so I'm going to have this this police officer stand here all day long and all night long, ready to go, just in case it happens. You're not going to get funding for that.
No.
But finding it, I think the Pan-STARRS telescope, was that the one that found Oumuamua, whatever. Yeah. That telescope it's not just sitting there collecting dust. It's looking.
It's actively looking. It's actively looking. And so the more samples we get, I guess, the more we can start to understand these things. Just like with exoplanets, just like with pulsars or quasars.
That's right. And in fact, this is one of the big trends in astronomy today. We talked about this very briefly, but rather than, just making a photo of one's patch on the sky and studying that at your leisure, make telescopes that can come back and look at the whole sky, or as much of the sky as you can see, every couple of days. It would be good if you could do it every couple of hours. It would be even better. But, then you're going to see things that, as they say, go bump in the night. In other words, things that happen frequently, but are very short, things you would never see. If there were some aliens out there and they were aiming a giant laser pointer in our direction and flashing it once every 2 weeks for 1,000th of a second or something, it's a brief flash, like a photo flash, right? Mm-hmm. Nobody would know. Nobody would know. You go out tonight, you look up and you see, wait, did I just see a little tiny flash there? And your buddy would say, don't drink so much beer or something. But new telescopes are going to be able to find stuff like that, and they will be able to find Oumuamua 2.
Okay, so that's all coming up. So even the laser pointer, that's like a brief flash. Is there a telescope currently being developed for something? That minute?
Yeah.
Really?
Well, not a laser pointer.
Not that crazy, but I mean, so we are actively going to look more than. May I ask how much would it compare to the software I had installed in the 90s? You know, what we were scanning. Everybody.
SETI at home.
SETI at home. That you still have that, right?
Well, it was never our project, I got to tell you. I don't want to disappoint you guys.
Really? I thought it was for some reason always connected to you guys. Oh.
I know everybody does, but actually,
okay. I'm so glad I'm not the only one.
Well, that's okay. It's a project of the University of California at Berkeley, actually, and they are still running.
Yes, they are still running, right? Yeah.
You can download it. So no, that's a very interesting project. But looking for brief flashes, yes, actually, here at the SETI Institute, there's a fellow, Elliot Gillum is his name, but he's building a very simple, inexpensive telescope that can find these brief flashes if they're bright enough. If they're not bright enough, then it becomes a much harder problem. But so, sort of look at the whole sky by having these things sort of spread around the Earth and looking for very brief flashes. It turns out you can look for that sort of thing. Yeah. But also, there's an instrument called the Large Synoptic Telescope. It has some acronym that doesn't mean anything in any language anybody speaks. But that's also designed to find stuff that happens, very quickly, things like that. Yeah.
And so it's just like it sort of comes across as a telescope that will just look in weird spots. That's sort of the how do you design for something that you don't know, like Oumuamua? How do you design for something that's just like weird to find? It's
But how do you decide where to look?
Yeah, how do you decide where to look?
Well, that's the whole problem of discovery.
Yeah.
Right. And that's exploration. You could have asked Captain Cook in 1770. All right, look, the British Admiralty is going to pay for this bad ship we're going to give you, and you just head out into the Pacific and map everything you find and write up the cultures and all that sort of stuff. And his problem is, okay, I got all these men sitting here on this ship. They don't want to be here. They're all going to get scurvy. We don't have much food. He has to decide where to go. He can't do the whole Pacific, right? Nope. Mm-hmm. So, that's a perennial problem. That happens all the time in astronomy. What kind of instrument, because they're very expensive now, what kind of instrument are you going to build to discover something you don't know about? Because that's the most interesting thing to find. So, of course, it's a problem. But what you can say is that the part of parameter space, as they love to call it, because after all, parameter space probably has a lot of Latin in it. But the part of parameter space that we've never been able to look at before are things that happen maybe more than once, but that happen very briefly, where a 3-hour time exposure on the sky, the way we used to do it with our telescopes, that's never going to see it, right? No. So let's build telescopes that can see things that happen quickly, but maybe rather intermittently. And so that's what they're building.
Yeah. Really great.
So is that the most interesting thing in SETI research going on right now, or would you care to mention something else?
Well, I don't know. It's hard to tell what's the most interesting until you find something. Then you can look back and say, wow, we should have done that earlier. But that's always the case, right?
No, that's with hindsight. But
that's hindsight.
Yeah, but
more
there's research going on. And what is most interesting to you right now?
Well, with our Allen Telescope Array, we're trying to look at 20,000 what are called red dwarf stars. These are very tiny stars, smaller than the sun, put it that way. There are lots and lots of them, and many of them seem to have planets. There's a system called TRAPPIST-1. That's because the Belgians actually discovered it. The Belgians are big on TRAPPIST over years.
Exactly.
Their peers. But that's because this is a monastery in Belgium. Well,
great right now.
Yes. All right.
So the Allen Telescope Array, and it's right. Where is it? It's close to you right now.
Well, as I say, it's 300 miles north of San Francisco. So, many people may not know the geography of California, but California is actually a very big state.
Oh, yeah.
And it has a lot of mountains because it's on the West Coast. And, so the movement of the continents is sliding California toward Japan at about the speed at which your thumbnail grows. So it makes all these mountains. So these antennas are up in a mountain valley. They're up there not because of the scenery, which, by the way, is kind of pretty and all, but it's because the mountains kind of shield the antennas there from all the radio noise that comes from here in the San Francisco Bay Area. So, Yeah, that's why it's up there. I say a beautiful place. In fact, anybody who happens to be in California, you're going to California. If you go to Northern California, you can go visit this thing during the week anyhow.
We will.
Is that the one where they shot Contact? Is that?
No, they didn't.
Okay.
No, Contact was shot at using the antenna down in Puerto Rico.
Oh, okay.
The SeaWorld telescope, but also the Very Large Array. That's where Jodie Foster actually finds the signal. Yeah, and that's in New Mexico. Yeah.
Oh, that's in Mexico. Okay. And so this one, so what are you going to? How can that help you find?
Well, it's to begin with. It's an antenna that we can use every day. For all the time, we can use it all the time. That's a big advantage when it comes to this sort of thing, because if you're looking for ET, you don't get a lot of money. We don't get any government money.
I was about to ask. Congress is very skeptical these days, aren't they?
Well, it used to be a NASA program. When I joined the SETI Institute, SETI was actually a NASA endeavor, and it took very, very little money. It was a few pennies per day. But it got killed by Congress for political reasons. So it runs on donations, and that means it's very little money. I have to say that SETI is a very interesting project. This is just kind of an aside, but that's done these days only by Americans. Only by Americans.
Is that true? Wow.
That's true. And I think that there's an anthropology PhD thesis in here somewhere. Yeah. I gave a talk in Holland. I don't know, 10, 15 years ago, I don't know what it was, at one of the universities, in Groningen actually, and about SETI, looking for ET, and the room was totally filled. There were people standing next to the walls, and I asked them, I said, how many of you think that there are aliens out there, intelligent beings? And they all raised their hand. They all thought that was a reasonable thing. But then I asked, how many of you are willing to spend 1 guilder a year, which was about 50 American cents, the price of a bad cup of coffee?
Yeah.
How many of you are willing to spend 1 guilder a year to look, not a guilder a day, a guilder a year? And all the hands went down.
What?
So
that's crazy.
Nobody should be looking for it. That's crazy.
You can have my guilder. You can have a euro as far as I'm concerned. You should do crowdfunding, by the way. Try that.
But that's what's so funny about it. So in one point, we're basically not really listening, and we're making these telescopes to listen. And on the other hand, people find it such a crazy idea that it's out there that they don't hardly even want to consider the possibility. So I'm glad that some things are happening. But if I understand you correctly, we're not really looking hard enough. Maybe because we don't really want to know the answer. I don't know.
I don't know what it is. I don't know because, the Europeans certainly, just to take the Europeans as an example, they certainly have the equipment to do this kind of work. They have the expertise for sure, and they have the money. To be honest, they could do it. And I asked actually one of the Dutch professors after my talk, I said, why is it that they're not willing to spend 1 guilder a year? They would think nothing of going downstairs, getting a cup of coffee now, but they wouldn't do that once a year just so we could find out if there are any aliens out there. And, he gave me an answer in Dutch. He said, daar zijn we te nuchter voor.
Daar zijn we te nuchter voor. Yes.
Yeah, we're too sober for doing that kind of stuff.
Way too sober. And the Americans dare to dream. I went to school for American history and American culture. So you're absolutely right. Maybe I should write my PhD thesis about why the Americans have this manifest destiny to keep on looking, sort of. Well, the Americans want to potentially colonize, and I think maybe even conquer them as well. These aliens.
Well, you could say that it's American imperialism.
You never know. You never know if that's part of the equation. But looking never hurts. Yes. No.
I don't think that's it. But I think that in a sense, you're right there because America's tradition, this is unlike many other places in the world, is a frontier mentality. The heroes in America are, the cowboys. You've heard of the word cowboy, probably. Cowboys. Guys walk across the mountains and go find new things and so forth.
Our podcast is
exactly. So we're just the cowboys. That's so there's nothing wrong with wandering off and checking out what's there, and then
Hey, but Seth, I said as a joke just a couple of minutes ago, you ought to try crowdfunding. But of course you do. You told us you are running on donations. Now, we do crowdfunding, but if any listeners care to donate money to us and to you as well, what should they do? How can they lose their money with you?
lose their money.
Until there's
Listen, it's like asking them to fund Christopher Columbus, right? I mean, that's what it's kind of the same thing. Well, it's simple, actually. You just go to SETI.org, organization, SETI.org, and that's our website. And if you're interested in helping fund this project, you'll find it.
Yeah, okay. And it's what you do is amazing, because I'm just so glad that people are looking. Anybody who is out there and looking in their own way, I think should contact us, or should start something in the rest of the world. I mean, this should be a global endeavor, right?
Yes, that's right. And in Europe, I should make an exception. There's one country in Europe that has done some SETI, and that's the Italians. But I think that the Italians have the same mindset as the Americans.
Yeah.
I don't.
Yeah.
Well, Christopher Columbus was an Italian, wasn't he?
Supposedly, yes.
Yeah.
Yes. Yeah.
Well, you just need a wandering spirit, and just think that, right now it seems like a fantasy. And what we spoke about last week is ET might be out there. It's just if it's intelligent or not. That's the question we're looking for.
Well, the advantage in the intelligent ones is that they might, get in touch some way. You might be able to find them. The other thing you can find, of course, are microbes. You could use big telescopes and examine the atmospheres of planets that are very, very far away. That's becoming more and more feasible. And of course, if you found oxygen in the atmosphere, lots of oxygen, you might say, well, they've invented photosynthesis, so maybe there's cabbage in space.
Who knows?
But as far as intelligent life is concerned, Seth, how do you feel about the argument that we should be careful because they might be more intelligent than us and dominate us?
Well, there is that argument. That argument became famous. The argument actually is not to worry that they might be more intelligent than us. I mean, you can worry about that when you go to college. The student next to you might be more intelligent than you are. But the argument is that you should maybe not broadcast. Yeah. Right? Don't send messages, hey, we're the Earthlings. We'd love to get in touch with you guys. Because if you do that, you don't know what's out there. And maybe they're aggressive and they launch a bunch of missiles your way and incinerate your planet. Which would, ruin your whole day. So that could be. But I think that whole argument, I think it's nutty myself. Because we've been broadcasting anyhow since the Second World War.
That's right. That's right.
So they already know about us. I mean, if you're going to worry about this, it's too late to worry about it. I think that this whole argument became considered a serious argument because Stephen Hawking at Cambridge actually made some comment about it, but only one comment. And one should keep in mind that if Stephen Hawking were to say, this is the dry cleaner I like to use for my suits, in Cambridge, that would have become famous too, because it was, after all, Stephen Hawking.
Mm-hmm. Yeah, anything he said.
Yeah, so it never hurts to listen is one thing you say, but on the other hand, who knows? It'll be a while before they're here. If we just hear a signal, we have 40,000 years or something to prepare for the onslaught. So we're safe.
Elon Musk. Okay,
you have plenty of time to buy some frozen pizza and hang out in the garage.
Exactly.
Thijs, do you have any more questions for Seth?
Enough to talk for hours and hours and hours. So Seth, hope to talk to you in the future again. Would be wonderful. It's
been a real pleasure, guys, and I always enjoy talking to people in the lowlands.
Oh, thank you so much.
We had fun.
Same for California. I love California. I was there a month ago, and I can't wait to go back. The weather. I mean, right now we have a Dutch winter outside. Our viewers can see it's just it's gray and
wet.
horrible and wet.
Yeah, and
I'd rather be in California.
Okay.
Thank you so much, Seth.
Thank you very much, Seth Shostak from the SETI Institute in California.
And thank you so much, Herbert, also for
Thijs Roos.
Yes.
Thank you.
And to our listeners.
This has been Space Cowboys Podcast.
Talk to you next week when we have Anthony Brown, and we're going to talk about ESA's Gaia project, which is great. They're mapping the whole Milky Way. And that's not only
fun.
Yeah, it's just not only about just looking, it's also processing all that data, because they're trying to store as much information as they can get from the entire Milky Way. So stay tuned for that one.
Okay. Bye-bye.
See ya.